So in our first video, we reviewed horizontal and vertical transformations and vertical stretches from grade 10. There is one more possible location for a number, but it doesn't really fit well with parabolas. So if you sort of think about this being kind of the base form of a parabola, something like this, stretch that out maybe. This is the vertex form of the parabola. So we tend to use those three values when we talk about how the parabola moves. This is my vertex 4, 3, right up here, because my graph has shifted 4 to the right and up 3. This number here determines the stretch on my graph, so it's going to be stretched up by a factor of 2. We do also have the possibility of having another number kind of squeezed into here that, again, we don't tend to look at in terms of what it does with the parabola. So we're going to look at that now and see what happens as we kind of go through some similar type graphs in a similar situation. Now, what I've done here, just sort of to let you know, I've hidden the f at x values at the bottom of the next few graphs. So I have 4 different graphs here, the equations of which you may or may not recognize. It's not really important. What is important to understand is that these numbers that we've just looked at, the 2 out front, the -2 here, the +2 here, similarly the +2, -2, 2 out front, they are all the same values that they were originally. So if I just kind of turn these ones on, you see that this +2 has taken this graph, whatever this graph happens to be, and raised it by 2. This x minus 2 in here says take whatever my f at x was before and put this shift of 2 on it that we saw from before. So again, regardless of what my f at x equation is, this has shifted my graph 2 to the right. And then similarly here, this one is saying double my f at x value, so make whatever my y value used to be twice as tall. And if we just kind of look at that, you can see that right here, I've got the point 1, 1, and here I have the point 1, 2. It's twice as tall as it was. If I change this right here to a 3, my value is now 3 times as tall as it was. If I change it to a 4, my value is now 4 times as tall as it was, and so on. And if I go to the other graphs and do the exact same thing, this graph has been shifted up 2. This graph has been shifted 2 to the right. This graph is going up twice as fast as the previous one. So we'll sort of check that again, bring this in here. Let's just see what we've got. 1.6, let's use that. And here I have the point 1.6, 1.6. Here I have the point 1.6, 3.2, twice as high. The y value is double what it was. The y value now is triple what it was, and so on. So again, the key is to recognize, regardless of what my original equation was, when I do a +2, my graph goes up 2 spots because I'm saying take all the existing y values and increase them by 2. Raise the whole graph by 2. This one says shift the whole graph by 2. Now you can't really see it because what I'm dealing with here is a sine curve. And the sine curve is talking about degrees. So the difference between 180 degrees and maybe 178 degrees or negative 178 degrees is very slight. So if I just change this number to make it a bit more obvious, 45, you can see that now the blue graph has been shifted over from this point here that was 270 and 1 to this point right here, which is 225 and 1, 45 degrees to the right. This point right here was 0, 0. This point right here will be 45, 0, and so on. Here's 90. Here's 135. And you can see that each of these points is now in exactly the same location, y value wise, but shifted 45 degrees to the right. And then similarly here, if I put the 2 out front, I'm saying double all my existing y values, and so this value now goes up to 2 when it was only 1. This value was 0, doubled is 0 still. This value was 1, doubled is 2. This value is -1, double it is -2. And then the last one here is a little bit strange to look at, but we'll sort of show that it does work the same way. My original graph is whatever it is. When I add 2 to the end of it, the graph moves up 2 spots. So let's turn this on. And so my graph here was at 1, 1. My graph here is at 1, 3. It's been moved up 2 spots. As I slide across, 2.6. My graph is at 0.385 for a y value and 2.385, 2 values higher, again, because I've moved the whole thing up 2 on that red equation. Similar idea then, turn that off. We have a shift to the right of 2 spots. Well, this thing was here, it's now here. Let's change this maybe to y now and see if that helps. We can see that those 2 points are on the same y value. It has been shifted though 2 spots to the right in the x direction. Similarly, slide this up. This point is at 0.25. This point is at 2.25. It's been shifted 2 spots to the right. And then this one might be a little tough to see. I guess if we switch it again, we can see that this point is 0.25 for a y value. This is 0.5. It is twice as high because I have doubled my y value. I doubled my f at x value. Slide this back a little bit. And similar sort of thing here. At any point in time, I'm just kind of choosing one at random. Here I have 0.769. I double that and I do get 15.38, 1.538. If you don't know, you can check it, but trust me, it does work. So the key to everything I just sort of went through, the number out front will always stretch or compress my graph. The value in here is always a horizontal shift, move me left or right. And this is always a vertical shift, move me up or down. So now the real question is, what does this last value do? What does multiplying the x by a value do to it for us? And our best place to go to figure that out is the sine curve. So if we look at what we have here, this is the original sine curve. And I'm interested in seeing what happens with this. And what we can sort of pretty clearly see is originally my curve goes up, down, and comes back up across 360 degrees. So if we look at this one, from minus 360 to 0, I get an entire what we call wave of the curve. From 0 to 360, we get another entire wave of the curve. When I do this, when I multiply my x by 2, I now have 2 full curves in that same distance. So in that same 360 degrees, I now have 2 full curves. If I multiply it by 3, I have, not maybe surprisingly, 1, 2, 3 full curves. I multiply it by 4, surprise, surprise, 1, 2, 3, 4 full curves. So what this number is doing is it's compressing my graph horizontally. It's squishing it sideways so that I have 4 full curves in the regular distance of 1 curve. In a more general sense, if I look at something like this one, put that 4 in here, what it's doing is it's making the graph narrower. Now that looks a lot like the graph of, a number out front here. We put something in here and it stretches my graph up. And if I find the right number, I could almost get the exact same graph. But they are doing 2 different things. The number out front is saying multiply my y values, so stretch it upwards. This one is saying multiply my x values, so it's compressing it in the horizontal. It actually ends up that my graph is 1/4 as wide as it would have been. And again, that makes a lot more sense when we look at it here. I've got a 4 in here. So I have 4 full curves in the span of distance that was originally 1, which means that each of my full curves here, or my full waves I should be saying, is exactly 1/4 as large as it once was. And then basically all the other graphs work the same way. If I do this one, there are I could fit 2 full of this curve in the distance covered by the one original. So it is half as wide as it once was. Going over here, this one will be really hard to see, but basically the graph is half as wide as it was. Again, maybe not a good example. This one now is 1/4 as wide as it was. It is half as wide as it was in the original. So one way to see this, if we look at a specific spot for which we know some values, we can see that at -2 here and +2, we have a y value of 4. The distance, therefore, is from -2 to 0 and 2 more. The x distance across here is exactly 4 units. When I look at my purple graph here on the inside, we see that the distance is exactly 2 units, -1 to 0 and 0 to 1. So it's, again, half as wide as the original was. If I change that, I still have my original being exactly 4 units wide, but now I've got this going from a half to a half is exactly 1/4 as wide as the original was. So, quick summary then. If we look at the various pieces, we know this is saying increase the y value by 2. This is saying change the x value, so shift me left or right by this distance. This value says multiply my original y value by the number out front. If it's a bigger number, it will stretch. If it's a number smaller than 1, it will compress. And this essentially is saying squeeze 4 of my graphs into the distance that was originally required by 1 of my graphs. Squeeze 2 of my graphs into the distance originally required by 1 of my graphs. So basically, compress my graph to be, in this case, half as wide as it was, or 1/4 as wide as it was. Or here, only fit half of my graph into the distance required. So between that 0 and 360, we only get half of a graph, which is to say that the graph itself will be twice as wide as the original was. Okay, so I'm going to stop there. It was a fairly long video. I recognize that it contained a lot of information. But basically, those are all the things you can possibly need to know about transformations. Again, major key, the original equation, what we call the parent function, whatever f at x is, doesn't matter. If we're adding on to the end of it, we're shifting it up or down. If we're multiplying out front, we're stretching it vertically. If we're subtracting in the brackets or adding in the brackets to the x value, we're shifting left and right. And if we're multiplying in the brackets by the x value, we are compressing or stretching horizontally. Maybe the last thing to leave you with, one of my students once said, the way I remember it, sir, is you can never trust your x's. And so in here, when you're subtracting from x, you actually are shifting to the right. When you're multiplying by a half, your graph is getting twice as wide. The y values do exactly what you expect. But again, you can never trust your x's. They will always do the opposite of what you anticipate.